Hello, everyone, and welcome to today's webinar titled How Amazon Creates Seamless Customer Deliveries with Amazon Redshift. My name is Manan Goel, and I'm the Principal Product Manager with the Amazon Redshift team here at AWS. Today, I have Lionel Aberdmain, who is the Technical Program Manager, and Arnaud Collin, who's the Senior Manager of Data Engineering with Amazon Perfect Mile team, with me as well. We'll be your speakers for today's webinar. In today's webinar, we'll start by talking about the challenges faced by Amazon as we deliver millions of packages every day to our customers. We'll then talk about how we solve these challenges with Amazon Redshift, and finally conclude with talking about the Amazon Redshift capabilities we plan to use in the future to further improve package delivery for our customers. With that, let me turn it over to Lionel. Lionel, welcome to the webinar.
Hello, I'm Lionel Abderrahman. I'm based in London, UK. I've been now in Amazon for the last 8 years, going through different roles, business intelligence engineers, software developer engineers, and today I'm going to present you one of the systems we've been working for the last 5 years, and how we were able to leverage Redshift to help the business deliver millions of packages.
Hey guys, I'm Arnaud. I started working for Amazon 10 years ago as a senior finance analyst. And today I'm a senior manager of data engineering working for Perfect Mile and using Redshift as my main backend. When we started Amazon Logistics 10 years ago, we didn't have any experience in last mile delivery. And it was actually the first time that Amazon would connect with a physical customer ever. In the early days, we had only one system based on an Oracle database. And as we started delivering more and more packages, we had to split the systems. And the data was coming through many microservices. We were receiving millions of events. And we had to store the data in one single database to be able to represent what was going on in the business. So as we were developing Amazon Logistics, more and more people wanted to see what was happening. And we had business analysts, finance analysts, data scientists who wanted to access the data. Redshift is a PostgreSQL relationship data warehouse that people could actually use as a single source of information and actually exchange data about this new business that Amazon was developing.
Our system is used by 32,000 users worldwide, and it's also which belongs to about 17 different organizations, businesses like Amazon Logistics, Amazon Air, fulfillment centers, sortation centers, and it's also used by from front-end operators that are working in warehouses that use our system website to bridge and understand what's happening in their shift, to regional managers who are using it to understand like what's the bottlenecks or the sites that are struggling and help them improve. So it's used. So it's actually used vertically. So we're able to produce KPIs for different businesses at a very granular level, to shipment or order level, and also horizontally. So all the people from a same organization, again from a front operator to a senior manager, are able to are using the same interface and looks at the same number. To be able to do that, our system have to consume data from operational systems from all these different businesses, and is also be able to consolidate all those data to be able to tell a story about shipments that are going through from the moment they are ordered on the website to the moment they're delivered to customers.
So what is Perfect Mile at Amazon? So our work consisted in putting together a lot of data streams that was impossible to process in other databases. So we are joining microservices data together and then surfacing in the data warehouse this information to finance analysts, data scientists, as well as within a website where we actually consolidate the data into metrics, KPIs, where operators in the warehouses can access the detail for each package and can actually drill down into the live package journey and understand what went well and what went wrong in the supply chain of this package. This allows us to understand the root cause of any operational defect, as well as system defect, and to actually course correct in the future the workflow and help Amazon to deliver better for the next orders.
So, in order to illustrate the complexity of the supply chain, let me try to explain the different components that we have to deal with, that the business has to deal with. The first one is the quality of the delivery. So, in order to improve and to be able to meet our promises, we have to mitigate a lot of uncontrollable variables, right? Like weather, traffic, and so on, which may delay deliveries. The second bit is the complexity of the network. As we're scaling up and as we are delivering more packages, it means that we have to have more people involved, more trucks, more nodes. And as we want to move faster, we actually introduce new programs. And each time we introduce one of these variables, we're actually increasing the relationship between all these different elements exponentially. And we always have to do that in a cost-effective way, which make it difficult and which also increase the number of data points we have to consider in our system. And the third part is the scale. Scaling means you have to be able to ramp up people faster, and you have to be able to operate while you're growing. Depending on the seasonality, you also have to handle the fact that your business will have to scale up and down, and sometimes quite aggressively. So those are the challenges the supply chain is facing, and that we have to support by providing insight through our system.
As we were learning to deliver packages along with our historical carriers, USPS, UPS, FedEx, and we got more and more information about what it was about in terms of operational processes. We actually, thanks to the data that we got, were able to scale a new company, a new delivering company, in just a few years. You have to imagine that UPS is 100 years old, and Amazon built a carrier in 5 years, almost, thanks to the systems that were behind the scenes.
There are 3 technical challenges we need to handle to support the business. The first one is the timing. We need to make sure the data arrive on time. The second is the complexity of the data we have to manage. The ecosystem, the complexity of the ecosystem. And the third is the scale in terms of the volume of data that we need to handle. On the timing, so the timing is about enabling our data consumer to be able to get the data when they need it. So in operation, in our cases, it means that we need to give them the data on a daily basis at specific times, so they have time to reflect on the actions that they've on what happened the day before, for example, and make adjustments to identify opportunities to do things better. So providing that data at a specific times is critical. It's like one of the top requirements from the business. The second is the complexity of the ecosystem. So the supply chain involve several actors. So you have the people that are handling the packages. You have the drivers, the trucks, the scans, the planning for each of those activities. This basically created, and you have like interaction between fulfillment centers, sort centers, delivery stations, and all of these activities create actually a complex environment. And in our cases, it translates in handling a very diverse volume, very diverse sets of data. So we are consuming about 500 data sources coming from 100 different teams, and that means we need to understand the connections between those different systems, so we're able to tell a story that's useful for our users. In terms of scale, so the scale is about our ability the challenge is on our ability to ingest and process large volume of data. And for example, in 2020, we had to ingest and process data that would help the business to deliver 4.2 billion parcels. And again, if you come back to the complexity, those 4.2 billion parcels have a whole story, right? From the moments they're out of the fulfillment center, the way they travel throughout the network to the moment it's delivered. So we actually have, and how it was planned, and we actually have to process data that enables us to understand and give perspective on how these parcels were handled throughout their journey. And that's translate, as you can see, on us having to process 400 megabytes of data every second for a full year. So to be able to tackle the challenge I just mentioned.
To give you a sense also on like how we were able to leverage the Redshift technology to process that volume of data. So we were able, so one of the data set that we're producing is called Delivery Estimate Accuracy, which is about basically our ability which define basically our ability to meet our customer promise. So our data sets not only tell you what's the ratio, like how good we are, but it's also telling you who within the supply chain, which process was responsible for a miss, following guidance provided by our leadership on how to make this allocation. So basically, our data set is able to tell you what's the bottleneck at at a very granular level. And before we actually, when we started using Redshift at the beginning, it took us 36 hours to process data to be able to provide an insight for the whole Amazon supply chain for one day. So which means that we actually needed 2 days, a bit less than 2 days, to be able to provide insight to our leadership about where there were opportunities, and through some optimization and where we were able to use and leverage the technology, we were able to put it down to lower it down to 8 hours. And that means, and that's critical for the business, because it means that before they could only have insight on what the trend was doing, and they could only try to correct the trend. But by putting it down to 8 hours, it means that they could actually fix whatever was coming or take action on saving customer promises, or and be more responsive in fixing challenges that they were able to capture thanks to the data in the supply chain. Before we get started on the infrastructure, let me try to illustrate a little bit the context when we started this project. So at the beginning, our team was supporting Amazon Logistics when it was a couple of stations, a dozen stations in the United Kingdom. When we started our project, there was not much traction because business mostly used to Excel reporting. So the initial motivation when we started was really about how do we move away from the limitation from Excel, especially as we start, processing more volume. So the business, as I mentioned, so it was not used to review KPIs on the website. So in order to get some feedback, we started a small POC with a few metrics. We demonstrated the functionalities on how we could dive deep, break down the data. And once we got the buy-in from the business, we came to an agreement at the time to produce about 30 metrics. I think it was Q4 2015. And the idea was, with those 30 metrics, it was to provide insight on a network that could deliver at most about 1 million shipments in a day at the time. So as the business learned to leverage and use the tool, get used to access to dive deep at a very granular level, the business starts to ask for more. So the demand actually increased significantly. So as I mentioned, we started the Q4 with an agreement of being able to process 30 metrics, but by the end of Q4, we were producing about 80 metrics. So we actually had to adjust our infrastructure to be able to to produce and scale significantly throughout the Q4 session, the Q4 period. And our initial solution, which was based on MySQL as a data warehouse, actually quickly hit the limitations. And we were processing data for too long. So we had to find an alternative. And this is where we transition our infrastructure our data warehouse from Redshift from MySQL to Redshift. Now, let's try to go a little deeper and let's go through how the overall infrastructure was looking like. So first, there was what we call the raw data, which is basically the operational system data that we consume as is. So we don't tamper with the data as it is. Then we consume that data in a data warehouse. So the first one that we used was a MySQL, in which we were storing the data coming from upstream, transforming it, and enriching the data, consolidating the data. And in the same data warehouse, same clusters, we were also computing the KPIs for the website or the PDF report that we generated out of the web of our platform. So our first choice was MySQL, right? And the main reason really was because we didn't have much experience in the data, and like volume was not the concern at the time. The concern was, how do we get a platform that where we could create and maintain KPIs without the support of software engineers. So once we managed to get that over the challenge, and that the demand increased, the problem switched from publishing those numbers to managing and optimizing the way we're processing data. And at the time, we're looking for a solution. As I mentioned, it was during Q4. So in the middle of it, especially as the business was processing more volume, we had to find an alternative to our relational database system, which was MySQL, and to find one that could actually process volume faster and more efficiently. And that's at that time, Redshift was an obvious choice. And that's how we started using and leveraging Redshift.
With Redshift, we were able to scale the volume of data throughout the years. When we started, we were only supporting Amazon Logistics in the UK. And today, we have dataset that gives insight on the whole supply chain in several regions, in North America, in Europe, and other regions. So through that journey, we did change our infrastructure. We adjusted our infrastructure to be able to keep up with the evolving demands and with the volume of data that was required to meet that demand. So essentially, our current infrastructure we separate our data warehouse in 3 different groups. The first one is the ingestion, which is used to consume the upstream data. The second is the transformation group, which is mostly used to consolidate the data and compute metrics. And the last one is the archive group, which is mostly used internally. Let me try to develop each of these. So on the ingestion one, so we actually adjusted. So each of these groups have our separate clusters. And the ingestion one has been tuned to maximize the computation power. We also, around those clusters, for the ingestion process, we also developed tools to facilitate the ingestion of data from multiple channels. We are able to consume data from API, S3, buckets, Kinesis Stream, SQS, and other channels. So the way we're looking at ingestion today is we're trying to organize our pipeline so we enable our platform to consume data on a continuously. instead of consuming data by batches. The main reason is that we want to mitigate the risks if a batch is missing. If it's smaller, it would have like less impact on your downstream, right? And it also gives you more flexibility in terms of timing. So that's what we're looking for in terms of how we're moving forward towards the way we're ingesting data. On the transform, we are also focusing and tuning our clusters to consolidate data sets and consume and compute metrics. And the last one on the archive. So the archive is used is actually configured to store data, not to compute. And the reason why it's used we want to have this cluster is to enable our team to investigate and improve or create new data sets, to explore the data.
So maybe let's talk a little bit in terms of what it means to consume data from upstream. So as we mentioned, timing is key for the business to be able to take informed decision that will be able to impact the customer experience. And that means that as we are evolving and as we are growing, we are trying to get closer and closer to the source of the events. So that means that we actually increase the level or the number of channels in which we are consuming data. So some of the extraction, when we say extraction stage, so basically so we consume that into an S3, and then from these S3 are like temporary, like act as a buffer to enable them to process and get that data into our Redshift. And that's the pre-processing, where basically we clean the data, we enrich it, like we all the time we make sure that timestamps are in UTC. We add some fields to understand like when the data was loaded and ensure that they are compatible before we get to process them into our Redshift clusters. So now let's talk about how does physically what we are talking about, like what system is looking like. Like from an ingestion perspective, we actually transitioned to our 3 nodes. And as you can see, we actually had to process about 51,000 queries per day just to consume data that's coming up to every 15 minutes. And of course, in our ingestion layer, one thing that we did really quickly is to limit the data to 45 days. So we only keep 45 days of data in this layer, which is basically based on what we actually need to do the transformation. Then the second part. So once we've done that, we ingest it. The data is ready. We put that in an S3, and then we transition it to the transformation layer. So this one is less intensive in terms of compute because the data has already been curated. And in this, we actually consolidate it. So this is where we connect systems together and produce those data sets. But we also use that layer to compute the KPIs, which basically require, as you can see, a lot of scans per execution.
So when we moved to Redshift, we were primarily doing end-of-day reporting. The data that we were getting was processed during the day, and in the morning after the day, we were producing reports and metrics to the operations. When it started to get fun is when we realized that Redshift was actually able to compute those metrics on an hourly basis. And then basically there was no limit in the creation of information for operations. One of the most fun use case that we actually got was about packages that were getting lost in the delivery vans. At this time, you had two systems, one for the delivery on the handheld device, and one in the delivery station when the packages were coming back in the evening. And one of the big questions that the operations had to figure out is that some of the packages were actually vanishing in the van. And then later on in the evening, other packages were actually getting back to station. What we realized is that the barcode that was used in the delivery system and in the source station system was not the same. And thanks to Redshift, we actually joined the information. And we realized that the packages that were returning to the station in the evening were actually the ones that had vanished behind the seat of the driver during the day. Then we could do, then we could actually change the layout of the van and get those packages into boxes and deliver more efficiently. Another use case is that since we were collecting data from all the supply chain, we were able to follow the life cycle of the package from the fulfillment center to the end customer, to the delivery. And since we were also able to refresh the data every hour, we realized that we were able to actually physically locate the package in space, thanks to the data that we were collecting every hour in the system. And we were then able to create a physical location in the report for operations to find where the packages were getting stuck, either into traffic or actually inside of a warehouse. We had another case just before Christmas where the objective was to deliver all the packages before the end of the day, so kids could actually get the packages on time for Christmas. And one of the reports that we created thanks to Redshift was refreshing every hour, 3 days before the day. The report was refreshing every hour before Christmas, and we were able to identify all the packages that were still to be delivered before Christmas. And this report was very hot for operations, published every hour, and Amazon was able to deliver most of the packages on time.
What was most important to get right in the journey with Amazon Redshift?
In our journey to leverage the Redshift data warehouse, we identify 4 aspects that we believe really helped us make the difference. The first one is the ability to process petabyte of data per day. Because the technology scale, we were able to maintain the same infrastructure for several years and keep up with the growth of the business. So we still did, of course, we still did make some adjustments, some optimization here and there, but the core of what the structure, the infrastructure we had didn't really change much. The second bit is the SQL interface. That bit is critical for us because it facilitates the way our data is accessed. It facilitates our interaction with our downstream stakeholders, our partners, and stakeholders. And this one is critical because this one is about the trust. So we're in a business of data. So that means that it only has value if the people using it trust it. And that's why it's so important to have an infrastructure where you promote transparency. The third is the power of compute. So the power of compute helped us also earn the trust with our downstream consumer in the fact that our data will be available on time and that we're able to consistently deliver this same experience on a daily basis, despite a surge in volume or changing the way the data or the metric is computed, we still, because we have such a power, the power compute really help us deliver this consistent, our ability to consistently deliver the data on time. The last is the data sharing. So the data sharing feature enabled us to reduce the redundancy of data in our clusters, and thus it also helped us reduce the cost.
So ultimately, thanks to Redshift, we were able to become the transmission belt between the business, operations, finance teams. And this was possible by documenting the data lineage, the data flows, making sure that the data was available on time, but also be flexible in the requirements and enforce the discipline among the community of data engineers and BIs to produce the metrics. So what are we planning next with Redshift? We have more and more data to analyze, and we would like to be able to identify deeper the bottlenecks and the roadblocks into the supply chain. Amazon is scaling very fast, is delivering more and more areas in North America, in Europe, in Middle East, in Asia, and the opportunities to deliver even better and faster at lower cost are huge. The other aspect of the development that we want to focus on with Redshift is the forecasting and the machine learning. Redshift is natively integrated with ML solutions such as SageMaker, and we are planning to leverage this possibility.
So, in terms of others innovation we're looking at is, as I mentioned, we just got started with the data sharing feature, and we actually have to rethink a little bit like how we are, how our infrastructure is set and reduce to reduce redundancy across across infrastructure that would help us also reduce the infrastructure costs. The other bit that we're also looking at innovating is, so one of the, as I mentioned, to be able to manage data sets that are reflecting different aspects of the business. Today, we actually have to have close relationship with each single businesses, and to coordinate and help them work together to deliver data set that they can leverage within their organizations. But the current system has some limitation because basically we are limited in terms of how fast we're able to be able to keep up. We're limited by the number of people we have, and what we want to do is to focus on our platform and have those teams contribute directly to our base code. And that's what we're looking at, is trying to find mechanism where the organization are able to work together and align with our system while we focus on scaling it up and reduce our impact on just on the coordination. Allowing team to so we want to allow external team to contribute to our code-based system, because one of the challenge we face once when we want to have data sets that are used and standardized across different organizations and different businesses is we are spending lots of effort just on coordination and just to be able to just on coordinations. And 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 as the company is scaling, the number of programs is increasing. Each of the business is becoming more habits, more and more are more and more complex. We want to move away from the coordination role and focus on scaling and enabling those teams to work together more efficiently. So we actually are able to scale better as a team, and yeah, that's why um, this is that would be like one of the next steps. We're also looking at innovating using Amazon Redshift, because we've, especially with the data share feature, we can have them work using their own hardware and then contribute to the baseline of the code that is used to process the data sets that are shared across all these different organizations.
Thanks, Lionel and Arnold. That was very informative. I learned quite a lot. On that note, we are going to wrap up today's webinar. As a reminder, you will receive an email shortly with a recording of today's webinar. We want to thank you for attending the webinar. And if you have any questions, please don't hesitate to reach out to us. Thank you.